Chapter 6 review.
Regular old review. Problem numero uno. List the ordered pairs shown in the mapping diagram. Then determine if it's a function. The ordered pairs are going to be the x values from the input and the y values from the output. They're points. How many points? 4 of them. And if you're like, how do you know? There's 4 numbers over here and 3 numbers over there. Because there's 4 arrows. The number of arrows is the number of points that I'm going to have. What's my first point going to be? 2, 9. It'd be nice if I knew how to write. 2, 9. What's the second point going to be? 4, 9. Third point, 6, 10. Ooh, 610. 610, dog. That's where I live. And then 811. Good. A function is a function if x's are only used once. If the x's repeat, then it's no longer a function. So do any of these x's repeat? Nope. You only go to one thing, you only go to one thing, you only go to one thing, and you only go to one thing. So determine whether the relation is a function. Oh, it's a function, all right. It will not be a function if I had an x value, which is 2, 4, 6, and 8, or an input or a domain that splits off and goes into 2 things. That's when it would be a problem. But we don't have that problem. For all of those who were like, that's trifling, Mr. Perich. That's super trifling. You have 9 over here, you being used twice. I don't care about the output. I don't care at all about the output. I don't care about the output. I don't care about the y's. I don't care about the range. As long as these guys are only used once, and they are. Hooray! Problem 1, done. Draw a mapping diagram. Ooh, a welcome change. Well, before we draw a mapping diagram, let's list out all these points, just for fun. We have time. -1, 2, 3, up 1, 2, 3, 4, 5. So that point is -3, 5. -1, 1. Ooh. -1, 1, 2, 3. 1, 2. One, 2, 3. 1, 2, 3, 4. Let's make a mapping diagram. Your book likes to use input. I like to use the word domain. One of you might be thinking, is it okay if I write out input? Of course it is. One of you might be thinking, is it okay if I don't? Of course it is, as long as you either call it domain or input, and as long as you call this range or output. I'm doing both because it could be both. All right, now in the domain, I put my x values. I have -3, -1, -1 again, 1, and 3. -3, -1, -1 again, but I will never write it twice. I'm going to close a couple things here because we're a little slow today. 1 and 3. My ranges are going to be all my y values. 5, 1, 3, 2, 4. I'm going to put those in order, which is 1, 2, 3, 4, 5. So my range is 1, 2, 3, 4, 5. Now I'm going to map them. According to my points, -3 goes to 5. -1 goes to 1. -1 goes to 3. 1 goes to 2. And 3 goes to 4. Is this a function? No. Why? Because that value right there, -1, is used twice. Also, from what you learned yesterday, you ready? From what you learned yesterday? Doot. Beep, 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 beep. It fails the vertical line test. So here's my mapping diagram, and it's not a function. Easy. Easy. Write a function rule for, all right, output means y. The output is equals twice the input to input is x. That's it. Output means y. You know that because I said it like a bunch of times. This is the input, which is also the domain, which is also the x values. This is the output, which is also the range, which is also the y value. Graph the function y equals 1 minus 3x. I hate the way that looks. Now, I could make a table if I wanted to, but I'm not going to. I'm going to take this guy right there. I'm going to take this John right there. And all I'm doing is rewriting it. And I'm going to say, I love slope-intercept form. And slope-intercept form look like this. Y equals mx plus b, where the number in front of x is the slope and the number floating around is the y-intercept. Well, it's not in the correct order. So y equals -3x positive 1. Now it's in the way that I like it. Now, some of you also might be saying, Mr. Perich, you just said if y is all by itself, then the number in front of x is the slope and the number floating around is the y-intercept. Why change it? I don't have to change it, but I did anyway because I could. What does that make my slope? Well, my slope is -3, or -3 over 1. That's my slope. What's my y-intercept? Positive 1. Always start out by doing the y-intercept. Go to your y-axis. Go down to your y-intercept, which is 1, and put a dot there. Then use your slope to make more points. This is a negative slope, which means it goes up and to the left, up and to the left, up 1, 2, 3, left 1, dot, up 1, 2, 3, left 1, dot. I ran out of space. Let me go back here. Down 1, 2, 3, right 1, dot. Down 1, 2, 3, right 1, dot. And he looked over what he saw, and he said it was good. Use the graph to write a linear function that relates y to x. All right, well, I showed you the linreg website. I'm not going to do that here Because, again, I know slope-intercept form says that a line looks like y equals mx plus b, where m is the slope and b is the y-intercept. So let's find the slope. My slope is, the graph is normal, up 1 over 1, 2. So my slope is m equals up 1 over 2, and it's positive. My y-intercept is right there at -1. So y equals 1/2 x minus 1. Easy. Does this table represent a linear or nonlinear function? This is not the same as a linear, or this is not the same as, is this a function? Yes or no, see if x is repeat. Nope. Linear means it's a straight line. I don't have a picture. So what I have to do is I have to find a pattern. And if it's the same pattern all the way throughout, then it's linear. If not, it's not linear. So what's my x values doing? My x values are add 2, 0 to 2 is add 2, 2 to 4 is add 2, 4 to 6 is add 2, okay? 8 to 0 is minus 8. 0 to -8 is minus 8. -8 to -16 is minus 8. So since all the x's did the same exact thing, and since all the y's did the same exact thing, this is linear because it follows the pattern. Okay, if you're wondering what the slope is rise over run. The slope is rise over run, or the y's over the x's. And each y is a -8. Each x is a 2, and so your slope would be -4 here because it's a straight line that follows a pattern. Not that I had to do that. All I had to do was say linear, and where it says explain, my explain would be like, well, the x's went up by 2 and the y's went down by 8. All of them, they follow a pattern, therefore it's linear. All right. More to do. The table shows the number of meters, y, a water skier travels in X minutes. Write a function that relates y to x. All right. So even though in the last problem I, was asked to do this, or not that problem, in this problem I was asked to write a linear function. I just looked at the graph and came up with it that way, and I said that's pretty easy. Now it's not so much. Okay. Now what I have to do is bring up my old friend. The line of best fit calculator. It's the air horn. Now what I'm going to do is I'm going to take turns plugging in all of those points into here and adding a point. So I realize this graph is sideways. It doesn't matter. The top ones are my x's and the bottom ones are my y's. So if my x is 1 and my y is 600, then I'm going to say that my x is 1 and my y is 600. Don't freak out over it. X is 2, y is 1200. X is 2, y is 1200. Three, 4, 5, 1800, 2400, 3000. 3, 1800, 4, 2400, 5, 3000. When I'm done doing that, I click on Show Line of Best Fit, and there's my equation right there. Remember, ignore the R. We'll talk about R in Chapter 9, which is the next chapter that we'll do. Y equals 600x. Y equals 600x. So when it tells me write a function that relates y to x, part A is y equals 600x. I'm going to skip B because I'm not going to graph it. I'm just not going to graph it. At this rate, how many kilometers will the water skier travel in 12 minutes? Okay, that's C. What do I do? Well, X is minutes, and I have 1, 2, 3, 4, 5, but it stops there. How do I find out when X is 12 way over? Oh, I know. I'll use my equation. Since my equation was y equals 600x, y stands for meters, and it wants to know how many kilometers. It's a trick. How many kilometers will the water skier travel in 12 minutes? So y will equal 600, and instead of x, I'm going to put in 12 because it asks for 12 minutes, and x is minutes. So instead of x, I'm going to put in 12. That's supposed to be a parentheses. And I believe that is 7,200 meters. Now, this is a trick problem because it asks for kilometers. So every 1,000 meters is a kilometer. So 7,200 meters is the same as 7.2 kilometers. Although I'd be very happy with that answer right there. They're both correct. A water skier travels at the same rate, but starts a minute ahead after the first water skier. Well, if they start ahead and they go the same speed, will this water skier catch up to the first water skier? Absolutely not. Because if they go at the same speed, they're just going to go, and the one guy is just going to stay behind each other. No. Terrible question indeed. The graph shows the prices of 2 stocks during one day. Describe the changes in the price of each stock. Ooh, I remember these. Let's get a red pen for stock A. So A will be, that's supposed to be a red pen. Okay, so let's be lazy here. At least let me describe it and then be lazy. It increases at a constant rate, stays the same, decreases at a constant rate, stays the same. So increases at a constant rate, stays the same, decreases at a constant rate, and then stays the same. B is going to be basically the opposite. It's going to start out higher, but decreases at a constant rate, stays the same as long as this guy did, then increases at a constant rate, and then stays the same. So the stock B, blue, decreases at a constant rate, stays the same, increases at a constant rate, stays the same. Which stock had a greater price at the end of the day? Well, whatever that one is, because that bar is higher. So red was lower than blue, which means the answer to B is stock B. B is B. Give a possible explanation for the change in the price of stock B during the day. I don't know. Maybe a new president decided to ruin the stock market? We don't need to answer C. Oh, look, the last one, and then we're done. You are competing in a foot race. You begin the race by increasing your speed at a constant rate. Then you run at a constant speed until you get a cramp and have to stop. You wait until your cramp goes away before you start increasing your speed again at a constant rate. Sketch the graph that represents the situation. All right. Time. Speed. Increasing your speed at a constant rate. Run at a constant speed until you get a cramp and have to stop. You wait until your cramp goes away, which means you're bottomed out. So you're down here. And then, just like we had up here in red, you start increasing your speed again at a constant rate. There it is. So that covers the bare basics of chapter 6.